Yeah, we'll post it on YouTube. So I would like to introduce everybody to Jered Dean. He is the fellow that runs the senior design program at the Colorado School of Mines, but he's had multiple other endeavors in his past working career, which are really awesome. So as usual, always feel free to interrupt him and say, hey, I got a question. Hey, I was wondering if you could answer a little bit more about that point, and then we'll have question and answer at the end. So with that, I'll leave it to you, Jered.
All right. So I'm not going to stick to prepare a formal presentation. These are some slides that I had put together for a job interview several years ago, and so I just pulled them up because they've got some good pictures of it. So I guess I'll tell you really quick my story, how I got here, and then I'd love to just answer questions and hear from you all. So I grew up in a little town in Pittsburgh called Pittsburgh, Kansas, which the only things that make Pittsburgh, Kansas famous that I'm aware of are our football team, which I was not a part of, and fried chicken, chicken ranch fried chicken. We won a national award for a fried chicken cook-off thing. And so we have some of the best fried chicken in the entire country. So those are claims to fame of where I grew up. I was a complete geek. I was really into RC car racing from the time I was in middle school through high school, and actually got sponsored to drive around in middle school and high school and race RC cars off road. Fun and silly, but I had a blast. When I got out of high school, I went up to Ely, Minnesota, and I was a trail guide for a summer, and would take people up on 10-day treks up into Canada, Mexico, and canoes, and I lived out of a backpack for 3.5 months. It was a blast. And when that summer was done, I came to Golden, Colorado, and went to Colorado School of Mines. So I teach there now, but I actually went there as an undergrad. And as an undergrad, I got a degree in mechanical engineering, but I also was really, really involved in a couple of things. I was really involved in the Formula SAE race program. Have any of you ever seen that? It's basically every year colleges will build a race car from the ground up, design and build it, and then go race it. And so I got involved in that early, really got into the analysis and the design and the learning how to weld and getting in a machine shop and building the parts, and I loved it. In the summers, I actually would travel back home and work in a machine shop at a manufacturing plant to help pay for college. So I liked coming back to college and sitting in and make stuff. And then I was also really involved in the anonymous writing as well. So we had a group of us that were really into playing guitar and music and all that. So we did that. I went out and I worked for a product development firm for about 4 years. And then I decided to go back and get my master's. And the one thing that I really, really hated when I was an undergrad was chemistry. Sorry, chemistry is wonderful. Does anybody else really try to avoid chemistry? And so when I went back to get my master's, I got to work with this amazing professor, and he said, here's the deal. I really want you to work on this biomass gasification stuff, turning wood chips into diesel fuel. But you're going to have to really be good at chemistry. And I'm like, no! So I spent 2 years doing nothing but chemistry, pretty much, to get my master's. But I learned a lot, and now chemistry is not so bad, it turns out, when you can apply it to make wood chips and things. When I was in industry, I did a lot of less awesome, or I think it was awesome, less flashy stuff called systems engineering, where we'd take really complex problems and break them down and try and, like with your projects. So how many of you were successful in immediately taking all your parts and just putting them together? Anybody? No? Okay, so how'd you do it? Or how are you doing? I know you're midstream, so it's an unfair question. You look it up? Oh wait, I heard specifically you were talking about, hey, I got my moisture sensor working, right? But I'm still working on my clock. Okay, so you're breaking it down into bits. bite-sized chunks. I'd call those subsystems or functions. And figuring out how each of those subsystems and functions work, and testing them and getting a feel for them individually, and then trying to plug them into one big thing that works. Well, the harder the problem gets, the more you have to really think through that and do that. So imagine, I worked at Atlas on the Atlas V rocket for a while at a Lockheed Martin. Imagine an assembly that's several stories tall, has a million some parts. The model of it is so complex that you can't open the whole thing on one computer. It doesn't exist at that time. How do you know? And so you had to design everything. You really think through, okay, we're going to design this, and it's going to fit together with this piece, and we're going to test this piece separately this way, and then plug it in, and then we're going to. So I did some of that. It's the way engineers think. And I think it's really fun to take a really hard problem and break it down into those chunks, like you're doing with your problems. And it gets even more exciting when you're trying to design a rocket or say Tesla Model S or something like that, right? I also worked on a lot of products, smaller stuff that was maybe flashier. So this was kind of a cool project. This was my team that I worked with, and the military came basically and said, we want to be able to seal in biohazards from like 45 feet away. We have this foam, we need some way to get a Marine in there to spray it all down. And so we designed this man-portable suppression system that somebody could grab and throw on, and imagine like a camelback for fancy foam that seals in biohazards. And so we had a team of about 6 or 7 of us working on this, and we worked with industrial designers, we worked with outdoor gear manufacturers, we worked with suitcase manufacturers, the military, all these different people to figure out how to get the right bits together. Turns out the pumps in here are actually the same pumps that supply the carbonation to alcohol or water, like for a tap system. We found out that those just happen to work really well for spraying foam. And so I did a dialysis machine, so we took dialysis machines at that time, were like this big. Everybody know what dialysis is? So if your kidneys are failing, they have to anyway, they have to pump your blood out, filter it, and then they pump your blood back into you. So it's like a blood filter for your body. And so we had to take a machine that was like this big and cram it down into the desktop size. And so we did the user interface, the industrial design, designed all the plastics, the pumps, and we didn't know if it could be done. We didn't know if it was possible. So we did, kind of like what you're doing here, where we rapid try it. So we built the simplest thing we could think of that would prove the theory, see if it worked. Try again. It did. We go, sweet. All right, let's move on to the next. A little more sophisticated goal. We built the first wireless electric vehicle charger. This was actually before electric vehicles came out. So I got just about kicked out of the DC Auto Show because Nissan Leaf had been released. The Chevy Bolt hadn't been released. We were supposed to design an electric vehicle charging system for these vehicles, and we had to know if there was space underneath to put the stuff we needed to put the charging out. And so I ran around the DC Auto Show with a camera and tape measure, sweeping under prototype vehicles, and they don't like it much. So this is actually out on the market now, and so you can get a Tesla with wireless charging. So just pull into your garage and plug anything in, and it just charges. Our team did that. Toys. all sorts of fun stuff. Ooh, this is my geeky claim to fame. This was the most complex mechanism I ever designed. And it was super cool. It's a paintball gun, basically. But the paintballs have something called capsaicin powder in them. Capsaicin is the active ingredient in mace, pepper spray. But we took it and made it 10 times more potent. And it was the consistency of baby powder, so if you got shot with one of these paintballs, it hurt. And then it threw powder in the face that was way worse than pepper spray. And so one of my claims to fame is this little unassuming gun took down an army raider. When you took him down, you didn't believe that it would stop him, so we said, so we shot him down. It also took me down in the middle of the night one time when I was trying to put this together and I wasn't paying attention and I accidentally threw a bunch of that powder all over myself, so safety first. Anyway, this whole cycle a ball would drop in, this barrel would shoot back, puncture a nitrogen canister, really high pressure air canister, and then shoot forward out of the gun about this far and throw the projectile all in less than 6 milliseconds. And so this was really fun. So those were the kind of projects I worked on when I was in industry. We did garage door openers. We did RFID. Actually, anybody know what RFID is? Played with that some maybe? Radio frequency ID tags. So it's the way that that was set on the back of the CD. You would scan it with the data speed. On the back of some of the stuff you bought actually were probably RFID tags where they used them for inventory control. And I designed the scanner that Walmart used to originally implement RFID in their warehouses. Smart pigs, toothbrushes, all sorts of stuff. It was pretty fun when I was in industry. I did about 8.5 years of product development. And then I went to school of mines to teach. I've been doing that for the last few years. And I teach senior design, which is a lot like what you're doing now, actually. We bring in clients and give our students really hard challenges and say, you don't know the right answer. There are a lot of possible good answers. Work with your clients and faculty and the resources you've got available to you to find a good solution. So those things ranged from having students working on remediating mine sites like in the Empire so that they won't push heavy metals into the water that comes down the river, to working on climbing the wall for the blind. So the students came up with a really cool system where you have a wristband and the climbing holes are smart. So as you get a wristband close to the climbing hole, the next climbing hole in your route starts being, so you can reach for it. All over the place. So robot tables, some other cool stuff. Well, Baja race cars, the Louis Baja race cars, marathon race cars, trying to get 1,000 miles per gallon out of a little car, that kind of stuff. So that's what I do now. Had 3 different startup companies interspersed in there, 2 of which were absolute failures. Well, one of them was an absolute failure. One of them I managed to break even on, but man, I wish I wouldn't do that one again. And the third one was actually really successful. But then I got the opportunity to go teach. And so the first one, if you're curious, was I was convinced that AA batteries were going away. And that at the time there'd been a breakthrough in membrane technology. So I was convinced you could make a AA size hydrogen fuel cell where you could just basically pour in some water and power your electronics devices. You're all thinking, why would I pour water near one of my electrical devices? We should have we proved that it was technically possible, but from a business standpoint, a really bad idea. senior, junior, sorry, junior, sophomore. Wait, rising sophomore, rising junior.
Summer.
Okay, cool. I've never heard that term before. So that means that you're transitioning. Okay. My son, my oldest son, just finished 3rd grade. I said, hey, so you're a 4th grader now? And he said, no, I'm a retired 3rd grader. So I'm learning all the new lingo here. So what do you think you're gonna do? Junior, senior?
Do you guys want me to look in your blue stamp applications?
Oh, I got applications.
I could tell you what you